Okay, so it is 7:10. We're going to go ahead and get started. I wanted to make a couple of comments first on the homework, just to make sure we're clear for future reference. So the homework is, I'd like it to be done, and this is so that I can take a look at it before I come to class and I can kind of look at what people have done. So I need the homework done by Monday night / Tuesday morning. So midnight, technically Tuesday morning, okay? So that when I get done with school, I can take a look at it and kind of look at what people have been getting right and getting wrong and stuff. So another thing about that homework, it is not a quiz. It is strictly homework for me to see how well you're mastering the stuff. So I am totally okay with you. Well, don't let other people help you, but I'm totally okay with you using your notes to help you. That's why I said use a lot of that practice work to kind of help you as well. So using your notes, using resource that you've got. What I don't want to have happen is, because this doesn't help you when you get to the test, like I know there's sites that you can just type things in and it will tell you all the steps and how to do it. Don't do that. That's not going to be beneficial to you. But use your notes, use the resources that you have through the website or the My Open Math website, and because again, that's not a test. It's not a quiz. It's just do what you can do. Show me what you know how to do, and so that I can give you and hopefully some feedback. If you've got questions on some of that stuff, please make sure to email me and let me know. I had a couple people email me at various times. I think all of them were today or yesterday. So maybe a little earlier in the week might be helpful. I can get back to you a little quicker because during the day I'm in school and I don't see my email until who knows when. So just be aware of that. Remind me of your name again, please. Melanie. Melanie Morales, right? Okay. All right, couple other things I want to mention right away here at the beginning. So homework by midnight, Monday night, Tuesday morning. That's the time frame. Again, use your notes, that sort of stuff. For this week, because again, I'm not sure that everybody understood what my purpose was for the homework and that you could use notes and things like that. I had a couple people referring to it as quizzes, and it's not a quiz. It's not like you have to put everything aside and time and anything. You take as long as you want on it. So what I'm going to do is, if you feel like for that first set of homework you needed more time or you weren't clear on what you were supposed to do for this week only, that's not going to be in the future, but shoot me an email and I will open yours back up again. At least I think I can do that. So I will try to open yours back up again, and so that you can finish whatever you weren't sure about. Okay, does that make sense? But I'm not going to do it for everybody because some people I'm sure are very happy with their scores as I was looking at them. So if you want that opportunity to redo it, shoot me an email and I will try and get that taken care of for you. Question?
I was completely lost on 1.3. Like
1.3.
Video.
Okay. Okay.
And for the exams, are we gonna have like a handout giving us this to practice? Because I feel like I would better like that.
Okay. Yeah. So there's going to be the review, and I can adjust the review a little bit. So the review has a lot of questions, and I can set it up so that you can print them out. Right now, I think it's set up so that it makes it really difficult for you to print it out, but I can change that so that you can maybe print out the review with physical paper to work through it or whatever. And then, to check your answers, you're still going to want to put it into the computer to have it check your answers and stuff. But there's a lot of different questions on there. You can always do the refresh and it changes the questions and stuff like that. So I do the actual paper, and so you'll be sitting down here with your paper and your calculator. Make sure you bring a calculator and paper. And so does that kind of answer your question or help a little bit? Or okay. But again, don't be afraid to email me. I know they have the tutoring up here, and I know some of you evidently went and talked to him and tried to get some pointers on certain things. And he told me this morning or tonight when I came in, he's like, I may come in and just sit in for a little bit to refresh my mind on what you guys are doing and stuff. So but don't be afraid to ask for help. Email me. I don't know if anybody used the form. I didn't get any notifications that anybody had. I checked it a couple times and there was nothing there. So I was like, okay, I'm not going to worry about it then. I think it's supposed to email me if somebody posts there. So, but please use those resources. So next week, we have our test over chapter 1. So let me talk a little bit about that so that you guys can be more nervous or less nervous, I guess. One or the other. So what we're going to do at the beginning of class is I'm going to go through and we can't spend tons and tons of time on this, but I'd like to answer if you had any questions on some of the review that there were just certain topics you weren't getting. If you could bring those questions to me and I can take a look at some of them and we'll just do them up on the board and go through them in case, we may spend 15, 20 minutes on some stuff like that just to refresh our memories a little bit, or if there's anything that you got stuck on from the review. So that'll be kind of the first thing we do next week. Then after that, we'll have our test. And the test is, it covers what we did in chapter 1. I will say there will not be any questions on concavity. Remember concavity? We did that last week, but there will not be any questions on concavity on the test. Okay? So you can kind of strike that one away. That's really more of a pre-calculus type.
Talking about the concave up and down.
Concave up, concave down. Yep. That will not be. Oh, sorry. When it's a picture, it's fairly easy, but when it's not a picture, and a lot of the ones they did were like, here's a table, figure out if it's concave up or concave down. So that won't be on there. The increasing, decreasing, which is we study that kind of at the same time, that will be on there, and all the other things. But concavity is more of a pre-calculus type topic, so we will not be having that on the test next week. And then I did tweak the schedule a little bit to kind of give us a little bit of a cushion for the following week, or the following weeks. So we will take the test, and the test I'm figuring around an hour. Okay. After the test, we'll take a break after that, and then we will come back and we'll do section 2-1. And we should be able to get out early next week because the test and the section 2-1 should not take up the whole time. But what that allows us to do is the following week we'll just do 2 sections, and the week after that we'll just do 2 sections. So hopefully those 3 weeks we'll be able to get out a little bit early, and we can get home earlier than 10 o'clock or whatever. So okay, so that's a quick kind of summary of the test and what the plan is for next week. But again, if you get stuck on some of those review problems, bring them in. We'll take a look at them, and like I said, 15, 20, maybe 30 minutes, go through some of that stuff, and then we'll get going on the test and stuff like that. So
Can we put this at our work
on
the homework?
No, I don't need to see that. The computer scores it. The one thing I will say, thank you for bringing that up. The one thing I will say is if you have a question, I know Ben mentioned that he had one where it said to estimate, and evidently it was looking for a certain amount of precision, and it was a little bit tricky. If you have a question that you think you did right, but it counts it wrong, maybe because you're off a little bit on your estimation, if you could just email me, I can override some of those grades, and the grade that's in there is not the grade that's necessarily going to go to Drury, and I'll be updating those grades for Drury here after tonight. But if you have something that, maybe you typed it in maybe a little bit wrong of what they were wanting, just, again, email me, send me a screenshot of, hey, this is what they wanted, this is what I had entered, and is that okay? Or actually just tell me and I can probably go look at what you put in. So yeah. On the homework?
Yeah.
Because what do you get, two tries?
Yeah, because on one of them I did better than the first attempt than the second attempt.
I'm not sure. I just looked at what it showed. Let me see what yours actually said, because I don't see both of them. I may have to go look at and see. It was on 1.2. And do you remember what you got the first time?
Like 89, I think.
Okay, and the second time 85. At least that's what it showed up for me. So I'll have to go back and check. I'll have to go back and check. To be honest, I was thinking I had only given you one attempt on it, so I'm not real picky about that. Like I said, I don't view it as a quiz. It's more so that I can see that you're working through the material and hopefully understanding it and stuff. So, okay. Remind me of your name.
Rosa.
Rosa. Okay. And did Victor come in? Okay, Victor. I knew somebody else had, and I just couldn't remember. All right, I've got everybody here. Artemio, is Artemio here? No? Okay. Okay. Let's get going with tonight. So we've got another 3 sections tonight. They are shorter than last week. I'll say section 1.1 was really long. Okay, but let's go ahead and get started. We're talking about composition of functions. Okay, composition of functions happens when the output of a function is then used as the input of another function. And we call that entire operation a composition of functions. So a couple things with our notation here. You'll see that this is one way to write it. F and then parentheses G and parentheses X. So what this says is F of G of X. And when we do composition, we always start on the inside. So if you see something that looks like this, it means you're going to use the G function first. And then after the G function, once you get that answer, then you're going to apply the F function to it. Okay? So just a quick illustration of kind of what that looks like. So have any of you ever bought something that you had to put together? No one. Just me. My wife buys me stuff all the time that I have to put together. Okay. So when you see the directions, it says directions, number 1, right? And then number 2, and then number 3. Usually you do step 1, and you do something, and you put something together, and then you take that item, and you move it over to step 2, and then you're supposed to take that item that you just built and add some more stuff to it, right? That's kind of what you do in functions. You do the work for the first function, then you take the result of that number, or whatever it happens to be, and then you stick that in and use it in the next function. So that's kind of the idea of composition of functions, or building Legos. You see that? You do this, and then you add this to it, and then you add this to it. A lot of things are like that when you have directions. Okay, and this is like direction number 1, the G function, and then F is the direction number 2, like the second step. Okay, F composed with G at X is another one. And so let's go ahead and see if we can get some examples of this. Another way of writing this is this notation right here. This is a little bit big probably, but this is the symbol for composition. It's not a dot, it's a circle, a little circle. It's not fog, but it looks kind of like fog. So this says F composed of G of X, or F of G of X. It's the same thing, it's just a different notation. Okay? So it means the exact same thing. You do the one that's closer to the X first, and then you move out from there. All right? So let's take a look at this. Suppose that C of S gives the number of calories burned doing S number of sit-ups, and S of T gives the number of sit-ups a person can do in T minutes. So this is a concept question. We're supposed to try and interpret, what does C of S of 3 mean? So what we want to do is we want to start on the inside. What does S of 3 mean? From what they told us right up here. 3 sit-ups. Not 3 sit-ups, but the number of sit-ups in T number of minutes. So it's how many sit-ups you can do in 3 minutes. And we all know that starts to slow down after a while, right? Okay, so this is saying how many sit-ups we can do in 3 minutes. That's what the S function tells us, how many sit-ups in a certain number of minutes. What does the C function tell us?
Calories.
Calories burned for doing a certain number of sit-ups. So when we put that and attach it to this part, which was the number of sit-ups you can do in 3 minutes, what is this whole thing telling us? Because the C is what? Calories. So it's the number of calories burned for doing sit-ups for 3 minutes. Okay, so you start with the S part, which S was number of sit-ups that you can do in T minutes. Then you go to the C. So it's the number of calories burned by doing sit-ups for 3 minutes. Okay, so it's a concept of trying to build through that and see what that's actually telling you based on that information. All right, tables are a little bit easier, usually. Let's take a look. Using the tables below, evaluate F of G of 3 and then we'll do g of f of 4. So first one, the first thing we have to do is g of 3. So which table are we using? The second one, right? And we're going to look at an input value, remember, of 3. So we're looking right here. What's the output for the g function when you have an input of 3? 2. Okay? So we have just figured out, I'll just write it under here, g of 3 equals 2. Right? That becomes the new input right here. So this now becomes f of 2. That output for the first function becomes the input for the second function. So now what's our, which table are we going to use now?
First one.
The first one, because we're dealing with the f function, and our input value is 2. So what is the output value now? 8. So we find out that the composition here, f of g of 3, equals 8. But notice we have 2 steps to get there, because we have to apply the g function, and then we have to apply the f function after that. Okay? The g function spit out a 2. The f function took that 2 and gave us an 8. All right? Let's try this one. What do we do first on this one?
4.
F of 4. Start inside the parentheses. F of 4. What does our table tell us that f of 4 equals?
1.
1. Everybody see that? F of 4 equals 1. Okay? So this then becomes g of what? 1. So the output from f of 4 becomes the input now for the g function. And what is g of 1?
3.
3. Input is 1, output is 3. So the end result is g of f of 4 is equal to 3. But you notice you have that kind of in-between step? It's not taking you directly there. You've got to do one thing first, and then you do step 2 to get the answer. Hang on, my mask is falling off. I don't want to contaminate anyone with math. All right. So let's try this one. Do this one quickly on your own. See if you can do these two on your own, and we'll see how it works. So f of g of 1, and then g of f of 3. Who thinks they've got the first one? F of g of 1. What do you got?
3.
Okay, so what did you do first?
You go to g of 1.
G of 1.
1, and then you transfer to 3.
G of 1 gives you a 3, okay?
Then you go to the first one.
And then 3 is the new input for the f function, and in this case, 3 gets sent to 3. So yes, that is correct. The first one is f of g of 1 equals 3. Anybody get a shot at the second one? Somebody else?
I got 2.
Got 2? Okay, what'd you do first?
F of 3.
F of 3, which that's boring because it's 3 again, right? And then we take 3, we put it in, and it gives us 2. That's correct. Okay. Questions there?
If that's the whole chapter, I'm good.
Well, it's not quite. So here's a graph, but we're going to do the same type of thing, right? What is this telling us to do first?
G of 1.
G of 1. So here's our g function right here. Remember, if you have g of 1, that's an x value, right? The
Yeah.
x value is 1. So we look over here when x is 1, and we go up on our function, and we find out, okay, the output for g of 1 is 3. Okay? Then what do we do with that 3?
You use it on the first graph.
We use that now for the f function, because this becomes f of 3, because we just figured out that g of 1 was 3. So then we go over here to the f function, and we go over to 3, and we go up. Sorry, that picture isn't super great. But what do we get for the final answer then? 6. Okay? So we can use a table or we can use a graph for input output. Okay? And if you've got a question, please ask. All right? Otherwise, we'll keep going. It's hard to read. Like I say, it's hard to read with masks on. All right, why don't you try these two? Or I guess there's only one. Try that one. Yes, I'm going to have somebody explain what they did, so be brave. Can I ask which function we're doing first? The F function, the one on the inside?
Fun one.
Okay. Does anybody have an answer? Somebody who hasn't answered yet, anybody have an answer for F of 2?
Yes.
You already answered one. You're going to wait for a while. There's a cool down period.
Move faster.
I think I do, I'm not sure.
What do you got?
Well, I'm on the other one though, so I'm.
Oh, yeah, I should be over here. Yeah, I was going to the wrong one.
That was a test. You done very well.
Like, I'm horrible at.
All right. So what do you got?
So it would be 5, because if you go to the 2 and go straight up,
Yep, 5. And so then this becomes G of 5. So we're off to a good start.
So on the quiz, are we gonna put G parentheses 5 or just 5?
Well, that's what's happening is this inner F of 2 is actually turning into a 5. Okay?
Because I'm writing it as like F2 and then equaling 5.
Yeah, and okay, that's another, because that is what we're saying is that F of 2 equals 5, but the whole point is then that goes in and that becomes the new input for the G function. But yeah, that's correct. Both of those are correct ways of writing it. So what do we get then for G of 5? G of 5. So here's our 5, right?
Oh, okay.
Looks like 3.
Yeah.
Okay? Is that making sense? So remember, X's left and right, Y's up and down.
okay, so how would you write the full answer then?
Okay, full answer. The full answer is actually just that one number.
Yes.
So we would say that's just the in-between step.
Gotcha,
The final product here is 3.
okay.
So G of F of 2 equals 3. Now on the test, if you get the right answer, I'm probably not going to worry about it. But if you get it wrong, I would really like to see what that in-between step was so I know what your thinking was. And if you had an idea but maybe just read it wrong, or if you really just didn't have any idea at all.
Do you give partial credit?
I will certainly give partial credit. Otherwise, I just have the computer give you the test, and that would be much easier for me. Just count it right or wrong. Okay. Are we good?
What happens if you do it backwards? Can you?
You can do it backwards. And if you do it backwards, it's not right. That's why we got to make sure we start on the inside and then get that part taken. Just like normal parentheses in math, we start inside the parentheses and work out from there. It's the same thing with these functions, these composition of functions. Yeah, but yeah, you could do it the wrong way. There is a wrong order to do it in.
Yeah, because it'd be -3. if you do it
Yeah,
wrong.
you get a different answer. Okay, so we have done tables and we have done graphs. The next thing we want to look at is what happens when we have formulas given to us. And so we are given the formula f of t, or the function f of t equals t squared minus t, and h of x equals 3x plus 2. Okay? Now I actually have to write some things down. So what are we doing first? Which one do we do first? H of
1.
1. So we're going to go right over here to this h function, and we need to know what h of 1 is. Now, do you remember from last week what we do if we want h of 1 and they gave us the function h of x?
Put in the 1 for every x.
Yep. So we have 3 times that x plus 2, and we're replacing all the x's, and there's only 1 with a 1. Okay? So 3 times 1 is what?
I don't know.
He's in a cool down period.
He's in the cool down period. We know this. What is 3 times 1? 3, and then plus 2? 5. So the first step gives us a 5, right? H of 1 equals 5. Now, again, we're not done. we've got to go back and do step 2. But that 5 goes right in place of that h of 1 because they're equal, right? H of 1 equals 5. So now what we have is f of 5. Does that make sense? And what does the f function tell us to do with this 5? Well, we're using this one right here now. We're supposed to take the input value and square it, and then subtract the input value. But what is the input value for us now? A 5. So we're going to put in a 5 here and a 5 here. And we have 5 squared is 25 minus 5. So the end result, and I'll write our final answer here, f of h of 1 equals 20. Okay? One of the most common mistakes people make is they don't do both steps. Or they do the wrong order. That is the other one that people tend to do on these stuff. How is that one? Is that making sense?
Yeah.
Okay? So the order is going to be important, and make sure you do both steps. All right. Same function, but I'm giving you a different input value and a different order. See if you can see how you do on that one. We'll go through it. I'm not going to make anybody do this one up on the board or anything. Come on up and do it. No, just kidding. All right, so you can check your own. We'll see how we did. First step is we've got to do f of -2. So the f function right over here, f of -2, is telling us we should take that input value and square it. It's the same function we did before, and then minus the input value. We are putting in a -2. So that gives us -2 squared is 4. And when you subtract a negative, you may have remember hearing this in the past, but when you subtract a negative, instead of doing that, you add the opposite. So you're going to end up adding a +2. So the end of step 1 is we get a 6. Okay, so f of -2 is 6. We've got to take that and put it back into here. So now we have h of 6. And the h function is telling us to take 3 times the input value plus 2. And our input value was 6. So 3 times 6 is 18 plus 2. And your final answer there, h of f of -2 equals 20. As long as I didn't make a silly little weird mistake. Okay. How do we do? Okay? Not okay?
I got something.
Did you get the 6?
I didn't do what you did in the first step, which I put 3 parentheses -2 plus 2.
Okay, so you did the h function first instead of the f. Is that what happened?
Yeah.
Yeah, so just make sure, always work from the inside first and then to the outside.
The trick, yeah, they switched it from the last.
Yeah, they switched the order. The other one was f of h, I think, and this one was h of f.
Oh, okay.
Does that make sense?
Almost done the same thing.
I know what you
Okay.
You
So
did the first equation.
yep, because they're telling us to do this one on the inside first, use that one first, which means we do this one first, and then we do, because if you switch the order, almost always, not every time, but almost always you will get a different answer. So you want to make sure that you're careful to do the order of what they actually say.
I'm confused on this.
Yeah.
Sorry.
No, that's
On
okay.
that, just like the first steps, I
This one.
understand how you got that, but when you have the -2 and 2,
This one.
where's all that coming from? So you have F and then you have the parentheses -2,
Yep.
which is in that top right part.
That's from over there.
Yeah, so after the equal sign.
And so we're using this right here. So they're using
Okay.
t as the input, and so we're just taking that t and replacing it with -2s.
Oh,
Does that make sense?
yep. Apparently I didn't see the rest of that.
Yeah. I don't know what color works the best for this, but anyway.
I missed the negative, but I know what I did.
Okay. Any other questions that people have? Questions are good. Questions are good. They're not going to bother me at all. All right. So let's take a look at this one. Now this is shorter and quicker, right? There's no composition here. This is from last week, right? We're just evaluating a function. So we're supposed to evaluate f of 3, which means we're going to do what?
3 squared minus 3.
Yep, 3 squared minus 3. That is 9 minus 3, which is 6. And then we're supposed to do f of -2, and we actually just did that one, which will be the same thing, -2 squared minus -2. This board shakes a lot. So this is 4, we said, and this ends up being +2, and we get 6. Okay, so notice we have 2 different inputs here, and they both give us an output of 6, right? And again, that's okay. What you can't have with a function is one input that gives you 2 different outputs, right? Does that make sense? So some review from last week. Okay, now, what happens, and again, this is a little bit from last week also. What happens if we are given this function and we want to evaluate f of a? What are we going to do? And don't make it complicated. We just do the same things we just did with the 3 and the -2, right?
A squared minus A.
Yeah, you're going to replace the t's with a's. And you don't need these parentheses. I just make that a habit because we can see, oh, what's in the parentheses here goes in these other parentheses. But this just becomes a squared minus a. When it's something really simple like this, f of t turning into f of a, the a's just replace the t's. And there's not even anything else we can do with it. Just leave it like that. Okay? We're building to get somewhere here, which you may or may not like, but anyway. All right. How about this one? So now we want f of x plus 2. So f of x plus 2. Now, if you use my method, it's going to make it really easy. I'm going to put parentheses and squared minus parentheses, right? What's going to go into those parentheses?
X plus 2.
Everybody see that? The x plus 2 is the new input that they've given us, right? That's your input, so x plus 2. Okay, and for right now, we're not going to worry about simplifying that. We're just going to get the concept of, do we know what that means when we're just putting that in place of the t? Okay, so those parentheses, at least for me, helps me kind of group what's going together, what's going on. Any questions there? So just replace those. Yeah. Yeah, that's probably not a great word. Honestly, evaluate means come up with a number. So I probably need to change that, but that's what the book had, and I just copied it. So sometimes I copy it, and I'm like, oh yeah, I should have changed that. But evaluate really means come up with a number. Probably a better way of doing this would be simplify, and then you put that in. But they use evaluate because a lot of times they do put in a number, and then your answer will be a number. But in this case, with a variable, you can't really evaluate. But yeah, if they, and I'm guessing the homework is going to probably say the same thing since probably the same people made it. So if they say evaluate and it looks like this, you're just going to put in the inputs in those various spots. All right. So how about this one? We've got, okay, let me show you how easy this is. Watch this.
I wanted to see you write it again.
What's going to happen this time? Well, we want f of m cubed, right? So what goes into the parentheses everywhere? M cubed. Okay, do we understand that? Now this one's pretty easy. Let's go ahead and simplify this one. At least it's easy if you remember your rules for exponents, which we'll find out if we do or not. Does anybody remember what the rule for exponents is if we have an m and then two exponents attached to it?
You multiply them.
You multiply those. So that becomes m to the sixth power minus, and then this one is just m cubed. And that's it. You can't do anything more. Because when you have variables to a power, unless those powers match up, you can't combine them.
You can't factor it out.
If we were, yeah, and that's the thing is, just because we can do something, you could actually factor. Because we could factor out from both of those in m cubed. Okay? I wouldn't worry about doing that unless the directions actually said to do it. Or eventually, we'll be doing something and we'll want to factor it out because of what the next step will be. But if all we're doing is simplifying, we just leave it there.
If I don't have to do that, I'm not going to.
All right, are we okay with that? Just putting that input in, and we did simplify this one. All right. Okay, so here's where we're going, and that's why we wanted to practice a little bit with those variables going in. So the first thing we're going to do, we're going to find both of these. The first one we're going to do is this one, f of g of x. And I'm going to write it all together so we can see it. So f of g of x. Now, this one, in some ways, is kind of nice because what is g of x?
Negative.
Negative 2x. We don't have to do anything to figure out g of x, do we? They just tell us g of x is negative 2x. So just like previously, we were substituting a number in here for step 2. Here we just replace the g of x with negative 2x. Is everybody okay with that? It's just a substitution. They told us g of x equals negative 2. We just put it in place of the g of x. You've got a worried look on your face. Are you okay? No, you're not okay. Okay. So right here, you see how it says g of x equals negative 2x? That makes sense? Okay. So if I know that g of x equals negative 2x, and we want to replace the g of x, the logical thing to replace it with is what it's equal to, right? And since it's equal to the negative 2x, we just replace it. Okay. Now we want to use the f function. Well, that's a boring f function. I'm going to change this f function because it's too boring for me. Let's make it.
Too simple or what?
It's not interesting. It's let's make it x, and I maybe just missed something when I typed it up. Let's make it x squared. Okay, so forget this. Make it f of x equals x squared. Okay, so what are we going to do? We're going to take our input value, and we're going to do what to it? With my new function. We're going to square it. Okay, now what do we have as an input value?
Negative 2x.
Negative 2x. Now remember, what does it mean to square something?
Double it.
Not double it,
Multiply by itself.
multiply by itself. And that's maybe what you meant, but that's not double. It actually means multiply by 2, right?
Yeah.
If you double 5, you get 10. But we want to multiply it by itself. So this means negative 2x times negative 2x. And what is, you just do the numbers, what is negative 2 times negative 2? 4. And x times x? Perfect. So we have just figured out and I'm going to put this up here in this other reddish color. We have just figured out that f of g of x is 4x squared. Okay? Now, what are they asking us to do over here? What's the difference? The order is opposite, right? So let's do this one now. So g of f of x. And let's see. Same type of thing here. I guess I'll put it underneath. That's what I did last time. What do we know that f of x equals? X squared, right? That's right here. So x squared. Okay, so that becomes our new input value. What does the g function do to that input value? It does -2 times x, right? But what are we replacing the x with? X squared. And so we get -2x squared. And that is our formula for the composition of this function. Or these two in that order. So notice, very rarely, if ever, are those two answers going to be the same. That's why it's so important that when you do them, you do the order correctly. You do the order, the right one first. Okay? I think my black is running out. I'll try and use green or red or something. I need to go to Sam's Club and get a big vat of markers. Okay, let's erase this stuff so we can see. Okay, a city manager determines that the tax revenue R in millions of dollars collected on a population of P thousand people is given by the formula R of P equals, and then 0.03 P plus the square root of P. And that the city's population in thousands is predicted to follow this formula. P of T equals 60 plus 2T plus 0.3 T squared, where T is measured in years after 2010. Find a formula for the tax revenue as a function of the year. Okay? So the idea here is that we're putting these two things together. We're doing a composition. Okay? Because the first formula gives us the revenue as a function of P. So let me just write this here. R of P equals 0.03 P plus the square root of P. Right? The function down here, P of T, gives you the population as a function of time. So P of T equals 60 plus 2T plus 0.3 T squared. Okay? Now you may be able to guess because of the letters they use. You see how this P is supposed to be input for the revenue function? And this function is giving us the P value. So find a formula for the tax revenue. Well, here's the concept. Does it make sense we would do R of P of T? Right? Because they're saying we need P to be the input, and here's the P, right? So that is the composition that we would have to do. So what do we have to do first if that's our composition? Which of those two functions? The P function, right? This is going to get ugly for a second. We're not going to worry about simplifying, but it's going to get ugly for a second. So that means we're going to have, I'm going to write it over here, R of, what do we know that P of T equals? This whole big thing, right? 60 plus 2T plus 0.3 T squared. That's what P of T equals. Now, what does the R function tell us we should do with that huge bunch of stuff? Well, it says we should take, I guess it's right here, 0.03 times P, I better make my parentheses big this time, plus the square root of P. And what goes into that parentheses and into that radical?
A lot.
All of this stuff, right?
Yeah.
That's our input. So 60 plus 2t plus 0.3t squared, and 60 plus 2t plus 0.3t squared. Again, we're not going to worry about simplifying that. That would be, first of all, you can't simplify it a whole lot anyway, but it would be worth it to try and do that.
It seems
Okay.
like Excel would really help right now.
Oh yeah, if you can have a function and you know how to program Excel to do functions for you, that it makes it very easy. Especially if you had to do multiple things of this. But so this is the idea. Here's what this function tells us. Notice our input value is t, a certain number of years after 2010, because that's what t meant. And based on that t function, that t year, this first function gives us the new population of the city. And then based on that new population of the city, the R function gives us the tax revenue. It was tax revenue, right? The tax revenue that will be generated for having that many people. So basically now, if you know the year, if everything goes the way it's supposed to, you can figure out what the tax revenue is. And if you're a politician, that means you can know how much you can spend. Twice as much as you brought in, right? Oh, wait, no, never mind. But that's the idea. Okay, we're putting those two things together. We're taking the time, which was related to the population, we're taking that and relating it to the revenue. Okay? All right. Domains of compositions. So we dealt with domains last week. Remember the two things we really have to look for with domains. We cannot divide by 0. That's probably the most clear one. You cannot divide by 0. It has no meaning. You can't do it. It's what we call undefined. Has no meaning. The second thing that you have to be careful of with functions in their domain is you cannot have negatives inside of square root symbols like this. Or really, this number up here is automatically a 2 when you don't see anything. But anytime that's even, you can't have a negative in here. Because there's no number that if you multiply by itself, you get a negative. Or that you multiply it by itself 4 times, you get a negative. Or 6 times, you get a negative. That's impossible with real numbers. Okay, so that, and when we deal with functions, we're typically dealing with real numbers, unless they tell us something otherwise. So that's gonna create those two things, dividing by 0 and having negatives inside of those radicals with an even index. That's what gives us the limitations on our domain. So as we look at this, let's start here. Which function are we supposed to deal with first? G of x. Okay? Notice G of x is right here. It has a limitation because there's a square root there, right? Does that make sense? What do we know can't be inside of there? A negative number. So here's what we have to say. This stuff inside of here, x minus 2, can't be negative. Now, how do we say that with math? We say it has to be, well, we could say it's positive, right? But here's how you say that with math. You say it has to be greater than 0 or equal to 0. As long as it's greater than 0, it's not negative. As long as it's equal to 0, it's not negative. If it's less than 0, then it's negative. So we would say this is greater than or equal to 0, and that would tell us that x has to be greater than or equal to, remember how we solved this? How do we cancel out that negative 2? Add 2, add 2. So x would have to be greater than or equal to 2 to be able to even be able to start being used in the G function. Anything else that you put in there that was less than 2, you'd end up getting a negative number inside. Okay, so that's the domain for this first one. But then we're supposed to take that result and put it into the f function, right? Now we're actually gonna simplify this a little bit, but it's not gonna be too bad because of what happens here. So let's think about this. F of g of x means we're gonna take f of square root of x minus 2. Right? Because that's the g function. We just put that in. Now what does the f function do? It says 1 over the input value squared minus 1. And what is our input value?
Square root of x minus
Square root of x minus 2. Now the nice thing, and this is why I said it's not too bad, what happens when you square something that has a square root on it? They just cancel out. So this cancels out with this. So this becomes 1 over x minus 2 minus 1. That makes sense? And if we simplify that, what does that say? 1 over x minus 3. Okay. Now, what's the limitation with fractions again?
The denominator can be
The
0.
denominator can't be 0. So we have to take this x minus 3 and we have to say x minus 3 cannot be equal to 0. If we get the x by itself, how do we do that? How do we cancel this minus 3 this time? Add 3. And I'm running out of space on the bottom of the board, so we're just going to put an arrow here. X cannot be equal to 3. So notice we actually have two limitations. One from the radical in the first place, and then another one once we plugged it in. So here's how we write the domain. Our domain is equal to, remember how we do this set builder notation? The set of x's. That means all real numbers x. And here's the condition, such that x is greater than or equal to 2. And what's the second condition?
Maybe 3.
X is not equal to 3. Notice if you just have that first condition, x could still be equal to 3, right? Because 3 is greater than or equal to 2. So you actually have a lot of times, not always, but a lot of times you're going to have two conditions because you're using two different functions. Some functions don't have any limitations. We like those. Just say all real numbers and we're done. Okay? But you want to start with, again, you want to start with this one first because that's the one that's on the inside. If we had started with this one first, 1 couldn't work, and also -1 couldn't work. So we don't have to worry about that because we're starting with the g function first. So that's why, again, it's important to make sure you deal with the correct one first as you're going through that.
What does our homework have? Our homework has us writing that another way.
Interval notation?
Yeah.
Okay, so the other way, if we wanted to do this in interval notation, because we want to know both, and the homework will ask for probably one or the other depending on, I think sometimes it does this and sometimes, does it do both of them? If I remember right, I looked through the assignment, I think it does both, but here's the other way. Or if you're doing interval notation, remember interval notation, you just use the endpoints of your interval. So this interval would start at 2 and go until 3. So that would say from 2 to 3, the 2 is included because of the equal sign. Remember what symbol that gets?
Bracket.
A bracket. And the 3, though, is excluded. You can't use the 3. And then we use this union symbol. It's a big U. And then the rest of the interval starts with 3, but doesn't use the 3. And then it goes forever. Anything greater than 2. So the way we write that is infinity, and infinities always get parentheses. So those are the two ways to write that. If it's me, I probably choose this one because I think it's easier when you're doing the work here. But you should start getting comfortable with both of those because you'll see both of those throughout the semester. Okay, the top one, remember, is called set builder notation. The bottom one is called interval notation. We just write down the endpoints for your interval. All right. Now, this last one is kind of the opposite of what we've been doing. It's asking us to break apart this function. So it says write f of x equals that as the composition of two separate functions. In other words, we want to break this apart into two separate functions. And there's going to be multiple ways to do this. So for instance, one way to do this is to say, all right, let this chunk be the inner function. And so I would just say, okay, I'm going to call this f of x is going to equal g of h of x. Okay, I'm just making up letters here. And I'm going to let h of x equal this inner part, square root of 5 minus x squared. Okay, and that's the first thing we're going to do. Then I could let g of x equal, what do you think? What's left that we need to take?
3.
It would be 3 plus x, that input value. And this is the input value that would go in there. And if you did this composition, you did the h function first, and then you plugged it into the g function, you would get this. Now again, I mentioned there's more than one answer here. So I could do the same thing, and I could say, oh, well, I want h to be, I'm a different person now, different student. I want h to be 5 minus x squared. In that case, the g function would be, any ideas? Because this time I'm choosing just this part. What does the other function have to do? Still 3 plus the square root of that other function, right? So that's not a huge major thing, but we've been putting them together a lot. We also want to know that, hey, they can actually be broken apart, but we still have to kind of keep the order in mind as we're doing that. There's probably several other ways to do it too, but those are the first two that quickly come to mind. Okay. Right. So that's the end. This one only has 8 graded problems. Oh, one other thing I forgot to mention. All of your assignments, when I put them into the grade book, they're all going to be worth 10 points. So like one like this, I know some of the problems take a little bit longer. You're going to get 2 free points because it's going to go in as out of 10. So you're going to get 2 free points. So, you know, Merry Christmas, Happy New Year, all that stuff.
So if I get 7, I actually get 9.
Get a 7, you actually get a 9. Don't tell anyone. Okay, no. So you get two free ones. I know some of these take a little bit longer because of the topic that we're covering. Okay, so that is our first section. We're going to take a short break here. It is a little bit after 7, so we're going to start at, no, it's a little bit after 8. I'm asleep already. So we'll start back up at about 8:15.